Hi, my name's John. Welcome to another Wednesday catch-up video. I've been on holiday for the last couple of weeks. I've been here with Deborah in the caravan to various steam rallies up and down the country. It was really nice. There are a lot of reviewers coming to say hello, shake my hand, and quite a few actually bought us a pint. There was one lad coming and give us a box of sort of a packet of tools. I'm going to show them on this Sunday once I get sorted through them. Some taps and some reamers, some really handy bits and pieces. You always end up with junk sales at steam rallies, like trade stands. I bought quite a few bits and pieces, some decent stuff, mainly to give away on my monthly giveaways. I'll show some of that. In the past sort of 18 Wednesday catch up, I've shown my lathe tutorial video. They're all finished now, but I have got quite a few tutorials or sort of tips on lathe work, not lathe work, on mill machine work. So tonight I'm going to put a video on about milling, all about climb milling, how not to climb mill, what climb milling is, because it's not difficult once you get your head around what you're doing, and it does make a massive difference, especially on a small machine. So that's going to be tonight's video. You can see I've got one of the early double boost caps on. I have still got some of the later double boost caps, and I've quite a few people have asked us, it's about time I did a new one, and I'm going to actually try and get some piss wobbly slack ones done. Probably a double boost logo with piss wobbly or piss wobbly slack, not quite sure. Right, that's enough talk, let's get on and have a look at today's video. Hi, my name's John, Big John. What I'm going to do today, I've found a blank for a tool holder for my lathe. That's the one I made. I've made quite a few of them. What happened was I got a lump of steel that they use for forklift truck legs. It's not hard, but it's very, very tough. I've got a friend of mine that's a big CNC machine, and he machined the dovetail slot in it. I could have done it myself, but it was easy for him to do it. I had a long lens, so I chopped open the lens. What I'm going to do today is machine one of these. So we'll be machining this square, we'll be fly cutting it square. Then we'll be going to mill a slot in there, which is that slot there, which our tool goes into. Drilling and tapping for the retaining screws that hold it in, and the stud that sets your height. So like I say, when I come to mill that slot in, I'll talk quite a lot actually about climb milling, what to avoid. Nice little project. They're quite expensive to buy. I've got a good dozen of them now, maybe a few more. I will be making some more. You can't have too many. It means every tool for your lathe is in a holder. It's already set in centre height. It's just a case of dropping it in, locking it in, and away you go. It saves a lot of time. Right, the piece we're going to machine, it only has one machine face, which is that face there. That was machined flat when the dovetail was cut. The rest of it's all shapes. So we've got to use that face as a register and machine off there. So the first thing I'm going to do is machine the face opposite it. It's too high, it's too low for my vise. Put a packing piece in. That lifts it up, so I've got enough height there. It's called a parallel. What you can use, I've got a selection of oil bearings here. You can use bits of oil bearings. Bearing tracks, centre tracks, outer tracks. They are going to be more accurate than anything I'm likely going to machine. So instead of using a flat parallel, I could use two of them. They're the same height, exactly the same height. I could use two of them like that. In fact, I'll probably do it that way. Yep, I think I will. Now obviously our vise, when I'm looking at it like that face there, that's probably the best unmachined face. That face is a slight angle. So we'll put the best unmachined face to the fixed jaw of the vise. Two spacers in. And when I try and tighten it, I can feel it's moving. It's actually pulling it out of line. So what you do, something round in the front. That's a piece of aluminium TIG welding wire, nice and soft, and a little nip on it there. Nip it. bastard. Sorry. So I look in there, those two, it's gripping on the two spaces underneath, and you can see the welding wire is taking the shape of the steel with it being soft aluminium. That's got a good hole, so I can go ahead and fly cut it. Take the drill chuck out. Drill chucks up for drilling, you put drills in, you drill holes, you drill and put milling cutters in. When you're fly cutting, it's probably called fly cutting because there's bits fly everywhere. Anything you don't want covered in bits of swarf and shite, cover them up. One thing you must do when you're fly cutting is you must wear eye protection. You can't be too careful with your eyes. If you hurt your hands, you hurt your hands. If you damage your eyes, not good. So please wear eye protection. I wear glasses, safety glasses. I wear glasses to see with. Before I wore glasses to see with, I was always at the hospital getting bits of shite out of my eyes. I've worn glasses for the last 10-15 years now, and I don't think I've been more than twice. Like I say, it's engineering, model engineering, it's a great hobby, but safety has got to be very high on your list, especially with your eyes. I can't overemphasise it. Right, we've got our fly cutter mounted. I've got the Y-axis locked so the fly cutter is in the centre of the workpiece. Like I say, the surface of this is nowhere near flat, so we'll wind it round to find the point. It's just touching there. And there'll be a good 40 or 50 thou drop between that face and that face. And again, it's just touching there. In one corner. Right, I've got it flat now. I want to put a finish on. I've put a 3 thou cut on. I've put a little bit of light cutting oil on the job. Power feed. The fly cutter's running at 300 RPM. Sounds happy, it's making happy sounds. You can tell they're not happy, they make nasty noises. Put a nice finish on. Before you stop the machine, make sure the cutter's well past the job. Yep, very happy with that. Some nasty rags on, I just knocked the rags off. Be careful, you don't cut your hand on the back of the tool, it hurts, I've done it. Just find a nice little chamfer on. I'll be going to machine a proper radius on here later on. I just want to knock the rough edges off so I can clamp it properly. So all it takes means you can clamp it. Also you wouldn't cut your fingers on it. See how the bit of wire took the shape of the job. So now we've got two faces, that face and that face there, parallel to each other. So we need to machine that face and that face, and there's nothing square. So what I've done, or what I'm going to do, I made a rear tool post holder for the lathe a while ago. I'm going to use that to hold them. It means I can put this on into the dovetail. I can lock that. It means I can machine that face square, turn it over and do the other side. The way I've mounted it here, we'll have to use the Y-axis to machine it. I'll turn it round, nip your vise up and give it a nice tap down with a rubber hammer. You wind your Y-axis, it's in the centre, lock it off. Same again really, find a high point, which I think is this end. It's just touching there. Yeah, this is the high end here. We'll zero that, still 4 days away with it best. Little bit of cutting bilge, a bit of oil. I'll knock the rags off, turn it over and do the other side. I will be going to put a pot of chamfer on here. So now we've got 1, 2, 3 faces done. Just enough sticking up to machine it. You don't want to try and keep things as short as you possibly can. So we're only fly cutting, only taking light cuts. Here, bastard. Right, that's locked off in there, so I can machine that, and then I've got the 2 ends to do, and then we'll come to milling the slot in there, which is the whole idea of the video, and I'll do a little bit on clay milling as opposed to conventional milling. Right, the block's all machined now. This is the last face to be done. Nice. Derag it. Now all 6 faces are machined, nice and square. Right, clay milling and conventional milling. The cutter is turning clockwise, all cutters do, well most cutters do. And the workpiece will be going advancing that way into the cutter. So the work is getting pushed into the cutter. That's conventional milling. If we take it across to the other side, cutter's still going clockwise that way, and what advance the workpiece in that way, it's going in, it's actually being pulled in by the tool's turning that way, it's trying to drag the job in. If you've got a machine with a lot of wear on it, or a lightweight machine, you can run into problems. That's clay milling. Clay milling's got its uses, you can get a good finish with clay milling. Personally I don't use it, or I try not to. Right, clay milling as opposed to conventional milling. I'll do a little diagram and see when I explain to you the difference between clay milling and conventional milling. I'll have a workpiece, like that, mounted on the x-axis. It's going to be going in that direction, feed that direction, from right to left. We've got a milling cutter going in right hand direction. Most cutters go in right hand directions. I want to take a cut along that edge there, so we'll fetch our cutter onto the edge there, going that way. The job's going in to the job is going into the direction of rotation, like that. So as that rotates, it takes a cut off that corner. It's being pushed into the direction of rotation. You find when you're turning the handle, you can feel resistance as it's being pushed in. That is conventional milling, or standard milling. Standard. Right, clay milling. On the other side this time, what our tool, still going clockwise. We'll put the cutter on the edge going that way. Cutter going that way, job going that way. What you find now is it takes cuts off that side just the same. So what's happening is the cutter, as it rotates, it tries to pull the job in. That's clay milling. Clay milling. So standard milling on the bottom, you're feeding in to the direction of rotation. Clay milling, you're feeding with the direction of rotation. So as you're going that way, when you turn the handle to feed it in, it feels like it's being dragged in. The cutter's actually pulling the work in. On a lightweight machine, or a machine with a lot of wear, you can run into problems with clay milling, dragging the workpiece in. Right, I'll put a bit of coolant on. Oh, I feed nice and slow, very, very slow. Everything's locked off, the table's locked off, the spindle's locked off. Doesn't take much coolant. Right, that's nice. Now if I wanted more, I put a bigger cut on and went, had the table coming this way into the cutter, that would be clay milling. The cutter would try and drag, the cutter's going that way, it would try and pull the job into it. And what I can do, I take the job out of the vise, table back that way. We've done one face. We'll do the other one. We can actually do 4 corners at this one setting. Put the water back on. Do it by hand. Doing a nice job. Right, we've done 4 edges all in one setting using conventional milling. Now we can do 1, 2, 3, another 4. That's it finished, you can see that. Nicely chamfered corners. So there's no corner that's a ding or if you drop it. Looks, you know, it looks nice, nicely finished off. Right, I've got a 10mm cutter set up. It's actually a cobalt cutter. It's set up in the centre of the job. I want a groove in there, 14mm deep. Just touching there, you can hear it touching. 0 and Z axis. cut. Lock it off. Cutting that, no problem at all. You can see it's a brand new cutter, brand new cobalt cutter. I'm only using cobalt because I've got a cobalt cutter given. You could probably cut 3 times as much as this, 3 times as fast. But I don't want to break the cutter, I haven't got another one. Bit more water. Heat's one of your biggest enemies in milling cutters. Bastard things get hot. Cobalt will stand a bit of heat. I could do more water on to flush the chips away, but the trouble is then the water pisses everywhere. Right, I've got a slot. At the minute it's 10mm wide, 14mm deep, which is the depth I want. I want the slot 16.5, so I want 3.25 taken off this edge here. I've zeroed the y-axis on the DRO. Turn it in. 1, 2, 3.25. Lock it off. And my Z-axis is locked as well. Right, so what I've got the cutter going that way, the job will be going in that way. Cutter going that way, job going that way, no good. That's climb milling. We don't want that. That will be turning like that, it'll be trying to drag the job in. That's no good, we don't want to climb mill it. So, back to zero. Right, we're back where we started, right in the centre. So this time we'll go 3.25 the other way. 3.25. So now we've got the cutter's going that way, that's the far edge is cutting, that's going into it, so it's going in to the direction of rotation. That's conventional milling, that's what we want. So I'm going to take it all out in one go, 3.25 down to full depth. So water it, stir it away, nice and slow. This is conventional milling. Now we want to cut this side of the slot. Back to zero, which is our centre. Right, zero, that's the centre of the job. And then it's 3.25, which is there, lock it off. So this time, our cutter's going clockwise again. We're going to go in that way, in the direction of the cutter. Conventional milling. Water. When it gets to the end of this cut, if I just dial some more feed in and fetch it back that way, that would be climb milling, not good. The machine will do it, I just do it like it. Exactly what I wanted. Right, so if I was to loosen that off, if that was, say I wanted another half mil out of there, I'll dial a half mil in, like that. That's running that way, and I'll set that away, run into it, cut that going that way, that will be klein milling, it will be dragging the job in, not what you want. Oh, you bastard. Well, you can see that's put a nice finish on. All it wants is a little bit derag around the slot, and there you are. There's another tool holder. One more to the collection. I'll drill and tap some holes in there. Same as that one. These ones haven't had the edges chamfered. I think you'll agree, chamfering the edges makes a big difference. Makes them look a lot more professional. There you go. Thanks for watching. Once again, it's just time to say thanks for watching, thanks for subscribing, thanks for all the well wishes and nice emails and letters that have been coming in regarding health-wise, at least mental health. I had a little bit of a sort of setback after the first weekend away. I was going to stop at a friend's house on the way back, and I just wanted to come home. So we'll come home for a couple of nights and then went away again. It's sort of, I'm getting there. I'm not the John I was, but I'm certainly getting better. Thanks mainly to my wife, friends, talking, a little bit of medication, but talking and sort of, you've got to talk. Anyway, thanks for watching.